First I will start with thermodynamics. Okay, this thermodynamics course actually most probably you have studied in your first year course. If you have not gone through it, so please go through before studying this whole course. And this first week course, I'll be briefing or I'll be summarizing the whole thermodynamic course and I'll be giving some example problem. A similar problem will be given in your assignment in your final exams. So go through this lecture, and if you think something is not there, you have to go back to your basic fundamental thermodynamic books. I have taken the maximum material from PK-NOC book, PK-NOC basic and applied thermodynamic books, this basic part. Okay, and this is Tata McGraw-Hill book. And if I take any other material, I'll give definitely. So what is thermodynamics? Thermodynamics is basically study of relations between heat and work, temperature and energy. Instead of between, I'll write among heat, work, temperature and energy. It is a macroscopic science. Macroscopic okay, it does deal with bulk system and does not deal with molecular constitution of matter. For example, random vibration of motion, Brownian motion, that we are not discussing in this course. We are discussing about bulk, fluid or volume, certain volume I'll take. So that volume will be compressing, decompressing, increasing temperature, reducing temperature. So whatever process we do, so we are not considering molecular, but we are taking bulk property. Okay. So distinction between machines and thermodynamics, mechanics and thermodynamics. Distinction between mechanics and thermodynamics. So mechanics concentrate on motion of particle of bodies under force or torque. Okay, so mechanics will be motion of particle under force or torque. But in thermodynamics it will be like concerned with internal macroscopic state of the body. Okay, so these two difference you should know. So what is macroscopic approach? Macroscopic approach, a certain quantity of matter is considered without considering molecular level. So matter considered without considering molecular level. Okay, microscopic now. Microscopic matter is composed of myriads of molecules. For example, you have Brownian motion, so particles are moving. So the discussion will be done through microscopic theories, and macroscopic we are discussing. So here this slide you see thermodynamics. One term is the therm and dynamics. Okay, so thermi actually the term is temperature and dynamics means force. Okay, so this combining these two terms, the thermodynamics word created. So here the definition properly written here. Macroscopic thermodynamic property, relationship between large scale bulk properties of a system. A microscopic system is the relationship between small scale properties of a system. Now thermodynamic system and control volume. We'll discuss open system, closed system, isolated system. So this is system. Okay, all are systems. Okay, this is also system. This is also system. Okay, so this is called boundary. Okay, and this is surrounding. Okay, the definition: thermodynamic system, a quantity of matter or a region in space upon which attention is concentrated in the analysis of a problem. Okay, so one system will have boundary, and outside the system that's called surrounding. Okay, now this is called thermodynamic system. System. Okay, so all these are thermodynamic system. So I'll define different types of systems. So it's called closed system. So this closed system is like this. The boundary is there, then energy out, energy in. Okay, and this obviously surrounding. Okay, a system and its surrounding called universe. A system and its surrounding is called universe. Okay, the boundary can be fixed or moving boundary. For example, you have piston cylinder arrangement. So piston is moving. The boundary is creating cylinder and piston. So piston can be moving. So boundary can be moving, or boundary can be fixed. For example, you take a bottle, and this is fixed volume. You increase temperature, reduce temperature. This is fixed boundary volume. But in certain cases, boundary can be moving. Okay, or changing shape. So closed system, no matter can cross. No matter can, mass or matter can cross the boundary. Okay, but in open system, this is let's say draw one open system. Open system, energy going, energy in, energy out, mass in, okay, mass out. So in open system, both can interact, energy and mass. But in closed system, only energy can interact, mass cannot change. Another can be isolated system. Okay, in isolated, what is happening? This is surrounding. Okay, from surrounding, there will be no mass or energy transfer. So no energy or mass can cross the boundary. Okay, so you should know the definition. So a system will have one boundary and it will be interacting with surrounding. If it is not interacting or no mass or energy getting transferred, then it will be called as isolated system. Control volume and control surface. Okay, so first draw one figure like this. Okay, and one motor is here, and work is getting transferred. Motor is working, you are giving electricity, so motor is giving work, or it is giving rotational motion or anything inside the system. Okay, air compressor. Okay, this is system, and then you are giving energy. So when you are giving energy, temperature will be increasing or it will be expanding, something will happen, right? And air out, air in, and this is called control volume. And control volume covering the boundary called control surface. Okay, so control volume, fixed identified region in space through which fluid flows through the boundary of the control volume It's called control surface. Fluid flows through the boundary. It's called control surface. Okay. And control volume is a fixed identified region in space through which fluid flows. Okay, matter as well as energy crosses the control surface. Matter as well as energy crosses. Okay, but in closed system, volume can change when matter flows. This is matter flows. The system is called control volume. So there is no difference between open system and control volume. There is no difference between open system and control volume. Okay, because volume can change when matter flows. The system is control volume. Okay, so closed system and control volume, open system and control volume, there is no difference because the matter is getting transferred. Thermodynamic properties, process and cycles. Okay, here several definitions will be there. State: when properties of a system have definite values, the system is said to exist at a definite state. Okay, now change of state. Change of any operation in which one or more properties of a system changes is called change of state. Okay, so this definition you should go through, and there'll be lots of books available, and you can learn from the books. Intensive property. So intensive property is like independent of mass. Independent of mass. So what are the independent mass properties? Like pressure, temperature, specific volume, or SP volume or SPV I can write. Specific internal energy. When something is per kg of mass, so that becomes intensive property because that becomes independent of mass actually. So energy, specific entropy, specific enthalpy, specific volume, specific internal energy, specific enthalpy, specific entropy, all this comes under intensive property. Okay, now extensive property. When you are talking about this comes like volume, energy, or anything related to mass. So that's called extensive property. Okay, now we'll go to process. Okay, process when changing state path is defined, it is called a process. For example, constant pressure process, constant pressure, constant volume. Okay, cycle: a series of state changes and final and initial state are identical. For example, one process is happening 1 to 2 and 2 to 1, 2 to 1, like this. So this is cyclic process. Process start from 1 to 2, again it returns back to 1. So it's called cyclic process. Okay, a series of state changes and final and initial states are identical. Final and initial states are identical. Okay, so state already I have shown here, like if I draw it in like VP diagram. So A to B is a process, 1 to 2 is a process, 1 to 2 is a process. Okay, 2 to 1 also process. But if I go to 1 to 1, sorry, 1, 2, then 2 to 1 again, then it's called cyclic process. CICLE, cycle. Okay. Now, homogeneous and heterogeneous system. Every substance can exist in any of the three forms: solid, liquid, gas. Okay. Now, single phase, homogeneous, only one phase is there. But if you have heterogeneous, that means multiple phases may be presented. For example, solid, liquid, gas, the mixture can be possible. So that is called heterogeneous mixture or heterogeneous phase. The thermodynamic equilibrium. This definition is like this: no change in macroscopic properties. Isolated system always reaches to an equilibrium and can never depart from it spontaneously. A system is said to exist a state of thermodynamic equilibrium when no change in any macroscopic property is registered. So macroscopic property is not changing if the system is isolated from its surrounding. Okay. Always isolated system reaches to an equilibrium state and never depart spontaneously. No spontaneous change in macroscopic property in the system that are found in equilibrium state. Because we'll be dealing with lots of force calculation and different calculations. So for that, there will be several units in SI units, in FPA units. So you should remember the units actually. Force, normally we use the term Newton, but there will be other units also you should remember. Especially SI unit, it is must to remember. But other like FPS unit or other unit, if somewhere it is being used, so that's also you have to remember. Okay. So force will be like dyne also will be there, Newton will be there, or maybe mega Newton will be there. So you should remember. So mass also you will have like kg, pound. Okay. So that units you have to remember. Torque, Newton meter. Okay. And other units also you should remember. Flow rate. So meter cube per second. And sometimes we use GPM, gallon per minute. If oil industry, if you work, then they'll be working as a barrel per day, and many other units may be possible. Power unit will be there, watt energy will be joule. Okay, these are common units I'm writing. Other units also possible, so you should remember whenever you're working or learning the marine engineering subject. Sometime I'll be using the terms and I may not define later stage, so better you remember all these terms. Heat will be like calorie, and it can be joule also. Temperature, different scales are there. For example, centigrade or Celsius, Fahrenheit, Rankine, Kelvin. Okay, so how to convert from one form to another form, you should remember the conversion also. Specific volume, when specific term is coming, so divide by something will be there. Specific volume is per kg. Similarly, specific enthalpy, specific entropy. So those terms also you should remember. So I have not given all the list here, but what are the common units for used in thermodynamics, any normal standard book if you see. So those units you should remember. Even you should remember how to convert from one unit to another unit also. Okay, so some definition I can give. Force equals MA. These are very basic equations you should remember actually. And G value equals 9.81. If I do not give any problem, you should remember meter per second square. Okay, so you should remember unit also. But if you are using FPS unit, then 32.2 feet per second square. Okay, pound mass, LBM we say pound mass. Similarly, pound force LBF, LBF, pound force we say. Okay, pound mass M. So mass and force are different actually. Okay, force, when you're talking about force, mass means certain matter. Work done. Work done, W equals F into distance. Okay, so distance can be M. So F is Joule and force is Newton. W is Joule and F is Newton and D is meter. Okay, if force is constant and distance varying, then W can be like integral form of F dx. Okay, SI unit 1 kJ, kilojoule. Here every time you should note down this K means kilo, this K is small letter. If you are writing K capital, the meaning will be different. Okay, normal SI unit says K should be small letter. Okay, so you write small k. And heat transfer, you use BTU also, British thermal unit. Okay, so called British unit. And conversion 0.746 kilowatt equals 1 HP. Okay, this also should remember. And force and pressure. Force means pressure means force per unit area. Okay, so force per area equals pressure. Okay, so force pressure unit will be like 1 bar or atmosphere. So that sort of unit you have to remember. 1 bar equals 100 kPa, Pascal, equals 14.5 pound force per inch square. Inch square or PSI, pound per square inch we say. Okay, torque, F into R. Okay, so force and radius you multiply. And torque means like shaft is there, you're twisting. So your marine shaft is there, you're twisting. Twisting means engine is producing power and propeller is running. So actually because of torque transfer, shaft is transferring torque. So how to measure the torque? Torque means radius of the shaft and how much force you're applying. So that is called torque. Specific volume and density. Density kg per meter cube. Okay, so specific volume is again per kg. It will be heat formula is like MST, T or del T. M is mass, S is specific heat. So here I am using specific heat. Later I'll be using S as entropy, so don't be confused. So just for temporarily I am using S as specific heat. You can use some other symbol also. Del T is temperature difference. So you take certain amount of water, increase 10 degrees to 30 degree temperature, and how much heat you have to give to increase the temperature. So you have to know the mass, you have to know specific heat of water, and you have to know temperature difference, like 10 to 30 degree means 20 degree temperature increasing. So my H calculation I can get. So that from there, okay, based on S unit you can get H unit also. S if is given in joule, then you can get H value in joule. So potential energy. So potential energy, potential energy, W equals integration of 0 to H F dx equals 0 to H mgh mg dx. Okay, how much this is from, how much the distance from surface is there. So that is H actually. So this distance is changing, that will be dx, and gravitational force is there G, so it will be mg dx. So finally it is coming mgh del PE, potential energy you can write. Kinetic energy, Kinetic energy W equals mv square by 2, not m square, mv square by 2 equals del Ke. Okay, a specific volume I already told, specific volume meter cube per kg, just opposite of density. Specific internal energy equals kj per kg. When you are talking about specific, normally it will be divided by something, so divided by kg here. So absolute pressure absolute equals gauge pressure plus atmospheric pressure. Okay, atmospheric pressure. Now we'll go to some basic calculations you may have done already from your +2 also during entrance examination. The similar basic calculation you can do so that you can remember all the units and how to convert, how to calculate. So here one problem is that a mercury manometer with one limb open to the atmosphere. Okay, so this is one pipe, okay, carrying gas with high pressure, and one limb is open to atmosphere. So this limb is open, this limb, okay, and other limb is connected to the pipe. Okay, if the difference in the height of mercury, here mercury difference is given z, okay, between two limbs 562 millimeters, so z equals 562 millimeter Hg. Okay, mercury given, so you need to know mercury density. The barometer reading is given 761 millimeter. That means their pressure is working, atmospheric pressure, this is 761 millimeter Hg. Okay, and acceleration due to gravity, different gravity is given. Okay, so G value is given 9.79. Okay, if G is not given, so you should take actually 9.81, but here just to confuse you, it is given 9.79. And the density of mercury is given, rho Hg is given 13640. Hg means mercury, this chemical symbol you can remember. Okay, this is Hg actually, chemical symbol. Now how to calculate it? So gas pressure, now you take one plane AB, okay, and here P equals PO plus rho GZ. So PO equals rho GZO. ZO is barometric pressure. ZO equals barometric pressure. Barometric pressure or height? Barometric height equals 761 millimeter Hg. Okay, rho is 13600 kg per meter cube, and P0 as more atmospheric pressure. Okay, PRESSURE. Okay, now P is rho G Z plus ZO, so that becoming 13640 into 9.79, Z1 plus Z2 0.562 plus 0.761, so this is becoming 177.10 power 3 Newton per meter square. Now Newton I got, now I want to get result in atmospheric. So you have to convert it. So it will be like 177 kPa. Now I got Pascal, kilopascal. Okay. Now from kilopascal, I have to convert to atmospheric. So 177, then divided by 1.013 bar. So it becoming, it is kilopascal is bar. So atmospheric pressure will be 1.746 atmospheric pressure. Okay. Divided by 1.013. Okay. So there is similar, again another problem, just little bit complexity I created. Here it is carrying steam. Okay, steam, and steam is getting condensed and getting deposited here. So Z1 actually 3 centimeter I have given. Okay, now A, B, my baseline. Okay, this is my baseline. So what is the left hand pressure? What is the right hand pressure? You have to equate. Left hand pressure, if this is P gas, so P gas plus your 3 centimeter water column height, 3 cm P gas, P for water. Okay, gas or steam? I should not write gas, rather P steam. Equals right hand side pressure, P Hg plus P atmospheric pressure. Okay, now barometer reading 76. So here it is coming 76.1 centimeter. Here mercury is given, this height is not given, so just you assume 540, maybe just assume 540 centimeter Hg, and water is 3 centimeter H2O. P steam we don't know. Okay, now P steam equals P Hg plus P atom minus P water. Okay, so P Hg means okay, so finally it become like 0.761 into 13.6 into 10 power 3 into 9.806 plus 0.5 into 13. This is not given. 0.5, 548, 54, 0.5. This means 500. Okay, 0.5. Then 13.6 into 10 power 3 into 9.806 minus 0.03 meter into 1000 kg per meter cube water density, 9.806. So it gives 167.876 kPa. So now we can convert into atmospheric and other things also. Okay, and I can make more complication also. I can make maybe another layer of some other fluid. Okay, so just you have to calculate left column side weight pressure and right column pressure, and you have to equate. So similar problem can be created for your assignment and final exam also. This is basic thermodynamics, so I did not go to very much difficult question, rather it is very simple +2 level question. So another problem, a pump discharges a liquid into a drum at 0.032 meter cube per second. This is flow rate is given. Okay, 0.032. The full drum holds 300 kg. So mass is given 300 kg kilogram. The diameter and height of the drum, diameter. Okay. Diameter is given 1.5 meter and height is given 4.2 meter. Okay, find density and flow rate liquid handled by the pump. Okay, density means fluid density. So here volume of drum, positive volume of drum. Okay, pi by 4 into base area, pi by 4 d square into h. So pi by 4 into d means 1.5 square into 4.2. Okay, this is giving 7.42 to meter cube, and density, therefore density equals m by volume. Mass is given already 3000 and volume 7.422. So this is giving 404.203 kg per meter cube. And what is the mass flow rate? M dot and mass flow rate. So volume flow rate into density. Okay, so 0.032 into 404.203. So it is coming 12.9345. Okay, kg per second. So this is your mass flow rate. Okay, so this is also a very simple problem. You can calculate.